In the last video, you have understood what is a PN junction and what are the parts we have in a PN junction, correct? So in this one, let's understand the working of a PN junction. Okay, now when we say working of a PN junction, understand when you have a P-type and N-type, what exactly happens and how the flow of charges are going to occur. This is what we are trying to find out. Okay, this is what the meaning of working of a PN junction. So first, you know that you have P-type, N-type. In P-type, holes concentration is more, and in N-type, the electron concentration is more. Correct? And also we know that when these two wafers, remember wafers from the previous video, when these two wafers are joined together, so first what's gonna happen? See, holes and electrons will start to move. Correct? This causes a current, what we call as diffusion current. This also we have understood in the last video. Now, diffusion current, what exactly is diffusion current? As the holes will move this side towards the N side and the electrons will move towards the P side. And as and when they are moving, the electrons and the holes will start to combine. This is one way of explaining this one. Okay, or as the electrons move towards the P side, they ionize the atom which is on the N side, correct? And as the holes will move towards the N side, then what's going to happen? In the P side, we are going to have negatively charged atom. And these atoms, they do not move. They are immobilized atom. Now, this causes kind of a no man's land, like a barrier. Like, okay, electrons cannot move, holes cannot move. It forms like a barrier. Alright. Now, this region, what we have, this region is what we call as depletion region. Okay. So, in this depletion region, it doesn't have any charge. Okay. And the atoms are immobilized. This region is what we call as depletion region. Now, depletion region plays a very important part, to be honest. Alright. Now, what you have the depletion region. See, in depletion region, if you look at this particular figure, now on the N side, you have a positively charged barrier. And on the P side, you have a negatively charged barrier. Now, don't you think this acts like a fictitious battery? That barrier what we have, that acts like a fictitious battery. Okay, like you have the positive terminal and the negative terminal, something like this. It acts like a battery, fictitious battery. Because it is like a battery, we have to have some electric field in it, correct? Because when you have a battery, you have positive, negative terminal. Between the two terminals, you will always have an electric field, isn't it? Now, this is what happens in a PN junction too. In a PN junction, between the P side and N side, once we have the depletion region is like a barrier. Okay? And this barrier acts like a fictitious battery. That means no more the electrons will move towards P side and no more the holes from P side will move towards the N side. It forms like a barrier. Fair enough? And it has an electric field of its own. See, once we have electric field, obviously potential will also set up, isn't it? So this setting of the potential is what we call as creating a potential barrier. Fair enough? So we have a potential barrier. Now, generally what happens, for silicon it is 0.7 and for germanium it is 0.3 volt potential, no? It is the volt. Okay, now see, you know that there is a potential barrier. Now, as the electric field is set up, okay, once the electric field is set up, what's gonna happen? The charge carriers, they start to drift because of the electric field. Sorry, not electric current. They start to drift because of the electric field. As they start to drift towards this particular barrier, now there is a current because the charges are moving. It's drifting, correct? Because of that, there is a current. This current is what we call as drift current. So you have diffusion current and we have drift current. So these are the two types of currents. Fair enough? Now, once potential barrier is set up, because you have an electric field, there is a potential barrier. Now, for two different elemental semiconductors, we understood what is it, isn't it? Now, this electric field and the potential, whatever we have. Now, what is the magnitude of the electric field? Electric field is potential divided by the distance. So, the distance is basically the thickness of the depletion layer. Now, depletion layer is around 1 micrometer, 10 power minus 6 meter, very, very, very thin. That means within a thickness of 1 micrometer, there is 0.7 volt of potential barrier. So the electric field is going to be 0.7 by 10 power minus 6, which is 7 into 10 power 5 volt per meter. It's a huge electric field. Don't you think so? 7 into 10 power 5 volt per meter is a huge electric field. That means when you have a PN junction provides an electric field of 7 into 10 power 5 volt per meter. And also it's going to give you a potential of 0.7 volt. Okay. So with the help of this one, we can change a lot of things. Okay. We can manipulate the resistance. We can manipulate the voltage, manipulation of current. We can do a lot of things with the help of this PN junction. Alright. So what exactly are the uses of a PN junction? You will see in the next video.